Hi Math 2 students. This is the last video in your Unit 4 review video series. And in this video we're going to analyze a polynomial function. Notice I've graphed one for you here. And I've asked you a number of different questions about this polynomial function. One of them is, what is the end behavior? So we like to look at what is happening to this polynomial as x gets really super big. In other words, as x is going in this direction. And we also like to look at end behavior in what happens as x is getting really small or really negative. So what we would say is as x gets bigger, what happens to y? Well, notice as my x gets bigger and bigger, my y is growing more negative. So we would say y gets smaller. And I'm running out of space here, so I'm going to abbreviate. So as x gets bigger, y gets smaller, and that would be a description of my end behavior on the positive side of this graph. But what's happening as x becomes more and more negative? So we would say as x gets smaller, what happens to y? And we notice that y is also becoming more and more negative, and it's going to exit the graph in that direction. So we would say y becomes small. And that's how we would describe the end behavior of this graph. When we analyze polynomial functions, we're also asked to describe something called symmetry. There are two kinds of symmetry. One is even, and one is odd. Now, don't get this confused with even degrees and odd degrees. Keep in mind this is an even function or an odd function without the use of the word degree. So I want you to take a look at the function and notice that if I folded this graph right here on the y-axis, each part would land right on top of the other part. This would land right there. This would land right there. In fact, this side is a reflection of this side across the y-axis. And when that's true, we describe our function as having even symmetry. So this graph is an even function. When I analyze polynomial functions, I'll also be asked to talk about the domain and range. So let's take a look at domain and range in terms of the graph we've been given. What I notice is that I have an x value for everything that I see graphed. And I also notice I have arrows indicating that it goes on and on forever in that fashion. So in this case, I would say the domain of my function is all real numbers. And I could write it like that, or I could write it like this and say that x goes from negative infinity all the way to positive infinity. Either way is an appropriate way to tell me that the domain of this function is all real numbers. So I'm going to write that down here in our analysis. I'm just going to write all real numbers. Now I'm going to look at range, and when I look at range I need to look at y values. So what I notice is these arrows indicate that y will continue to become more and more negative. So I know that I've got all these y values down here that are negative. But as I go up the graph, I notice that I get to the top where I don't have any more y values bigger than these 2 points right here. And the y value at these 2 points right here is 2, meaning the largest y value I will have in this function is 2. There's never going to be a y value of 3 or 4 or 5 or anything really bigger than 2. So when I specify the range of this function, I have to say y is less than or equal to 2. And that's how I tell that's how I describe my range. Now we're asked to describe the interval on which this graph is increasing and on which this graph is decreasing. So the way I like to do this is I like to divide the graph into the turnarounds. Notice right here my graph turns around. I'm increasing, and at this point I turn around and I begin to decrease. So I'm going to carve up my graph into sections where I have turnarounds. And you'll notice that I have 3 of them. And what I'm going to do is I'm going to notice that right here I am increasing. If I had a bug crawling along my graph, that bug would be increasing in height. And here I am decreasing. And again, if I had a bug crawling along my graph, it would be decreasing. I turn around here and become increasing. And then again at this turnaround, become decreasing. So now we have to figure out how to describe that. And how I'm going to describe that is I'm going to say, well, this part of my graph is from negative infinity all the way up to this point right here where x is negative 3. Notice I'm talking to you about intervals of x. So this says that x is in between negative infinity and negative 3. And I'm increasing on that interval. But between the x value of negative 3 and 0, I've started decreasing, haven't I? In between these two values of x, negative 3 and 0, I'm decreasing. Then I begin to increase again from the point where x is 0 to the point where x is 3. Right in here, I'm increasing. And then when x is 3 and on up to positive infinity, I begin decreasing again. So what I would put for my answer is I would say I'm increasing on this interval and on this interval, and I'm decreasing on this interval and this interval. And that's a pretty fair analysis of my polynomial function.